The very first step in module production is the glass. What you see here is an automated system that's going to pick up the glass, and this glass is the glass that is the surface, what we call the sunny side of the module. So this is the side that the sun is going to shine on. Now if we take a step back, you can see this machine here. This machine is a glass washing machine. What it's going to do is it's going to wash the glass and prepare it for the next steps. We want to make sure that the glass has no dust, no oils from fingerprints. We want to make sure it's as clean as possible before we go to the next step.
Like a dishwasher?
Absolutely. It's very much like a dishwasher at home, except without the soap. And we have a couple brushes in there that are going to do a little scrubbing. Make sure the night glass is nice and clean.
So basically it's very simple but effective.
Absolutely.
So tell me about this process that I can see in front of me. It sort of looks like a conveyor belt.
It's definitely a conveyor belt. What happens is in our system here in Meyer Burger, we're fully automated, or I should say semi-automated, which is a little bit different than most factories. What we have is the glass coming from the glass washing machine that we just saw a moment ago, and the glass is going to come over here. What we have on these big rolls that you see up here, this kind of semi-transparent material, this is called ethylene vinyl acetate, or EVA. This is the material that's going to bond the module together, and it's basically like the piece of glue that's in a sheet form. This is an automated cutting machine. It's automatically going to cut the EVA to the size of the glass. It's going to be a little bit larger. You can see here it's a little bit larger than the glass. This is because it shrinks during the lamination process, which we'll talk about later.
We're standing in front of a machine, the likes of which I expected to see when I came to Meyer Burger. It looks very complicated. I'm sure you can enlighten us a little bit about it.
I hope so. I hope so. In my hands here, just to show you, we have a cell. A cell is what is the most important part of the module. This is actually what produces the energy when we talk about a module. Without the cell, we wouldn't have anything. On the cell, you can see we have a grid pattern. We have some small lines and we have some big lines. These are called bus bars. These bus bars, if you will, are the highways to pull out the energy and where the electrons are going to come out of the cells. What this machine does is it takes these cells, which are loaded here, and it takes this ribbon here, and it basically solders on the ribbon onto the bus bars like this, so that we have a way to move the energy out of this cell into the next cell. So this is basically the connection from one place to the next.
So what's the next step in the process now?
The next step in the process is what's called layup. This process here involves the robot that we saw earlier picking up the cells. What you see here is the glass that we had earlier with the EVA, and the glass is now sunny side down. And what happens now is the robot's going to place it in line with each other. This placement is very critical. The human eye can notice big deflections in alignment. So what we see here is if the line of cells is not perfectly aligned or a little bit crooked, from a cosmetic standpoint, it doesn't look good, and the customer doesn't like that.
So if it wasn't completely straight, would it still work anyway?
If the cells are misaligned a little bit, the panel will work fine. It's very similar to having a scratch on a Ferrari. You buy an expensive Ferrari, you want it to look perfect. Here you're going to buy a nice, beautiful panel. We want it to look perfect as well when it's on your home. So the next step we're going to go to is going to be called interconnection. This is where we're going to connect the string of cells together that we've placed on top of the module.
I see.
What they're doing is we have several strings on top of each module. And what they're doing is they have to connect one string to another string. This way, when the energy is produced by the cell, it flows in a pattern. So here what they're doing is what we call interconnecting. They're taking a larger ribbon and they're connecting all the strings together. You can see here making the soldering from the small string or the small ribbon to the large ribbon there. And so now this puts all these strings in connection to each other so that we can get the energy of the entire panel combined.
Now that we're seeing them being all connected together, what could something like this perhaps power?
In this case, I would say it could power a small motor. A water pump, you know, if you're using one panel like this, you can definitely power a pump to pump water in, say, Africa or in Saudi Arabia if you have a deep enough well. It could do something like this, but it wouldn't be enough to power a home. We would need more power than this.
Well, that's quite impressive actually that we're seeing now in front of us one panel that if it was in somewhere with a lot of sunshine could be used, as you say, for a water pump.
Definitely, definitely. So now we're coming up on the laminator. The laminator is basically where all the magic happens.
I see.
Unfortunately, you can't see much inside the machine, but basically what we have is we have our module that's not glued together yet. All the pieces are separate, and it's basically going to be heated up and compressed. So what's going to happen is we have a plate on the bottom that heats it up and a plate on the top that just keeps pressure on the top of it. And all these components are going to melt together. The two sheets of EVA are going to turn into liquid, and they're going to all basically meld together like a grilled cheese sandwich, if you will. You got two pieces of bread, cheese, melted in, you've got one thing together, one sandwich, if you will. And that's what happens inside this machine. The machine's quite long because we have a couple different stages, but basically you have a heating stage and a cooling stage.
So this, after the cooling stage, then is the final process when we receive our grilled cheese sandwich.
If you will, it's ready to eat, ready to serve at this point. We have one final check that we need to do. And if we come over here, I can show you the flasher that's going to do that final check for us.
Okay, so most of the process is over. It's time now for a little bit of quality control, as it were.
Exactly right. If we come over here, we can actually see the final step, which is going to determine how much energy each panel is going to produce.
So this is the test before you release the panel out onto the market.
Yes, and it's an absolute must for every module that's released into the market, whether it's by us or anybody else. We do that with this machine here. It's called a flasher. This is also made by Meyer-Burger as well. And what the flasher does is it mimics the sun. Inside the flasher, we have a strong xenon bulb that's going to mimic the UV spectrum and also the power that the sun's going to provide at a certain specification. The panel will move here, and the panel will be flashed as it's connected to measure how much voltage is created from the panel, how much energy is created by the panel.
So basically it's a box with a really bright light.
Absolutely, that's basically what it is.
And you certainly wouldn't want to go in there without your sunglasses on.
Only if you want a sunburn.
Okay, fantastic.